Next we move on to gas chromatography. So gas chromatography is a sophisticated instrument technique. It uses instruments. Sophisticated means costly instruments. Now let us look at the principle behind gas chromatography. So here again, the stationary phase can be a solid or a viscous liquid. The mobile phase is a gas. Principle is differential migration and the mechanism is adsorption or partition. Gas chromatography is applied for identification of volatile organic compounds. These are generally found in air pollution, exhaust gases or industrial exhaust and all. We can find many volatile organic compounds. And physical separation is not possible, only identification can be done. So you can identify what are the different components in a mixture. The advantage compared to TLC is that we can apply this for a mixture containing a large number of compounds. TLC is generally applied only for a mixture containing small number of compounds, a few compounds. Okay. But if the number of compounds is very large, we have to use gas chromatography. Let us look at the instrumentation, how the instrument works. So this is a diagram of the instrument. Here you take the gas. This is a cylinder in which you are taking the gas. The gas is called carrier gas. Carrier gas. Okay. And this is the column. Again, here also you are using column. But the column, it is not like like that in column chromatography. We are using very thin columns, 5 millimeter thickness, 5 millimeter diameter columns only we are using, but the length will be very high, large length, about 10 meters or 50 meters, 100-meter length column. Okay, so since it is very long, these columns are wound into coils. Okay, like this, it is wound into coils, and mostly the column will be made of stainless steel. Stainless steel columns. Inside this, the stationary phase is filled. Okay, and this column is kept inside an oven, thermostatic oven, and it is always kept at high temperature. Why it is kept at high temperature? Because the mixture of components should always be in the gaseous state. Only then they can be separated. Because the mobile phase is a gas, so the mixture of components also should be in the gaseous state for proper separation to take place. That is why this column is always kept hot. There is an injector here, sample injector it is called. So through this, the sample, the mixture of compounds is injected using a syringe. It is injected into the column. And then at the outlet you have a detector. This is a detector. Detector will detect the compounds that are coming out, and it will measure what is the amount of this compound. That result goes into a computer. The computer generates the final result in the form of a graph, and that graph is called a chromatogram. Chromatogram. So this is the instrumentation of a GC. Okay, so hydrogen, nitrogen or helium, these are used. Most commonly used mobile phase is nitrogen, and the sample is injected using a syringe. The column used is very long columns with small diameter, made of stainless steel. Columns are wound into coils, and the columns are always kept heated. So this is the computer which generates the final result. So this is how the instrument is working. Now you start the experiment. You allow the mobile phase to pass through this column, and then you inject the sample. So when you inject the sample, the components, they will vaporize, they will get absorbed, and after different time intervals, each component gets desorbed, it comes out, it reaches the detector. Detector will measure what is the amount of this component. The result goes to the computer. Computer will generate the chromatogram. So this is how an experiment works. This is a photograph of a gas chromatograph. Okay. Column. The columns, there are two types of columns that are commonly used. One is called a packed column, which is made of stainless steel, or another is a capillary column. Packed columns, they have length 1 to 10 meters. Capillary columns have length 10 to 100 meters. Diameter of packed column is 1 to 5 millimeter. Capillary column is 0.1 to 0.5 millimeter. So these are the two types of columns. A capillary column gives better separation compared to packed column, but capillary column cannot be used at high temperatures. Like the maximum temperature will be somewhere around 250 degrees centigrade. Packed column can be used at higher temperatures also. This is a packed column, a 10-meter packed column, and this is a 100-meter capillary column. This is a syringe. It's a micro syringe of capacity 10 microliters that is used for injecting the sample. The sample is taken in the liquid state, it is injected, and it is vaporized. Detector. Different types of detectors are used. That is, some physical property of the carrier gas changes when a component from the sample is present. Okay, so the carrier gas, if it is passing through, it does not have any change, but when a component desorbs from the column and mixes with the carrier gas, its property will change. The detector measures this change in physical property of the carrier gas and feeds the information to the computer. Okay, so three types of detectors are mainly used: thermal conductivity detector, short form is TCD; flame ionization detector, short form FID; and electron capture detector, short form ECD. These are the three types of detectors which are commonly used in gas chromatography. So one important question: discuss the terms carrier gas, columns, stationary phase, detectors. Discuss the terms, means just you can define what is a carrier gas, what is column, all that you can define. How does a gas chromatography separation work? Stationary phase is packed into columns and kept heated. The sample is injected into the column. The carrier gas is passed through the column at sufficient pressure. The components desorb at different time intervals and passes through the detector. The detector measures the amount of component as electrical signals and a plot of signal intensity against retention time, that is the chromatogram. Retention time, it is defined as the time for which a component is retained in the column. This is an important derivation, important definition: time for which a component is retained in the column. So this is a sample chromatogram. What all can you understand from this chromatogram? So number of peaks tells you how many components are there. Okay, so here there are 3 components. There are 10 peaks, there are 10 components. Okay, the number of peaks tells you how many components are there. Then the intensity of these peaks will give you the composition. How much percentage of each component is present, it will give you the composition. Okay, each peak represents one component in the mixture. Now instead of using this intensity directly, there is another way which is a little more accurate to find out the composition, and that is the relative peak area. Relative peak area means it is area of each peak divided by total area of all peaks. So this relative peak area is directly proportional to the composition. Composition in terms of weight is called weight percentage. A composition in terms of weight. The relative peak area is directly proportional to the composition. What are the advantages of gas chromatography? Used in minute quantity. You can use it for minute quantities also. Complex mixtures can be identified. Large number of compounds can be identified. If a mixture contains 20 compounds, that can also be identified. Rapid separation. You can get the result within 30 to 45 minutes. Highly efficient technique. So these are some of the advantages of gas chromatography. Limitations: cannot be used for physical separation of the components. Cannot be used for non-volatile compounds, like for example sugars, glycosides, or acids, organic acids. These are non-volatile in nature, so they cannot be studied using GC. Expensive technique. The instrument is costly. What are the applications of GC? Testing purity of compounds. Studying air pollution, a very important application. Studying air pollution. Detecting carcinogenic compounds in water. Forensic analysis, clinical analysis, etc. Distinguish between retention factor and retention time in chromatography. One important question. Distinguish between retention factor and retention time. Just write down the definition, that is enough. Retention factor, that is distance traveled by component divided by distance traveled by solvent. Retention time, the time for which a component is retained in the column. Explain the principal, instrumentation, working and applications of GC. A 10-mark question. Normally this question will be asked. Detail the chromatographic technique used for separation of components in a volatile organic mixture. Same question as 18, but the only difference is it is put in a different way. Okay. Detail the chromatographic technique used for separation of components in a volatile organic mixture. So, which chromatographic technique it will be? For a volatile organic mixture, it is gas chromatography. Then detail means write the principle and the working. Principle and working is enough. Now we have seen earlier that gas chromatography is classified into two parts. One is gas solid and the other is gas liquid chromatography. Let us compare these two, gas solid and gas liquid. What are the points of comparison? In both cases, the mobile phase is a gas. Here the mobile stationary phase is solid, whereas in the other case stationary phase is a viscous liquid. Solid is packed into columns. Viscous liquid is coated on inert solid. Mechanism is adsorption. Here mechanism is partition. Good thermal stability. Whereas here thermal stability is less. But gas liquid has larger range of separation. And also it has better resolution of peak. Resolution of peaks means the thickness of the peak. Actually peaks should not be very wide. It should be narrow peaks. Okay, so you will get a better resolution when you use GLC. Generally, capillary columns are used in GLC, whereas packed columns are used in GSC. Okay, the instrument is the same, only then the column will be different. Same instrument, you can change the column. You will get GSC and GLC together. So that is gas chromatography. Make a comparison between GSC and GLC. This is a question that can be asked for a university exam. The last technique, high pressure liquid chromatography, it is similar to GC. It is an instrumental technique, but the only thing is here we are using a liquid as the mobile phase. Okay, a liquid is used as the mobile phase. Instead of the word pressure, some scientists use the word performance. Both are same, high pressure or high performance liquid chromatography. Stationary phase can be solid or viscous liquid. Generally it is a solid. Viscous liquid is used only in some special cases. Mobile phase is a liquid at high pressure. Principle is differential migration and mechanism is adsorption or partition. This technique is applied for identification of non-volatile organic compounds. Non-volatile organic compounds and physical separation is possible. That is a difference from gas chromatography. In GC, physical separation is not possible, whereas in HPLC, we can do physical separation also. How does the instrument work? This is a block diagram of the instrument. So here you have a solvent reservoir. It's a reservoir here. It's a bottle actually, in which you take the solvent, take the liquid mobile phase, and using a pump, you are pumping this mobile phase at high pressure into the column. Okay, at high pressure into the column. The mobile phase is a liquid, and you are using a very high pressure and pumping it into the column. Now column here, we are not using long columns as in GC, we are using only short columns, 30 centimeter length short columns. But the particle size of the stationary phase will be very small. Okay, it will be very small, and so separation of the compounds will take place faster. The 200 atmospheres, that is the pressure at which we are pumping, and we are using short columns of approximately 30 centimeter length, and stationary phase is of very fine particle size like nanometer size. Okay, then here you have a detector. Detector will detect the compound that comes out. It will measure the amount that is transferred to the computer. Computer generates the chromatogram. Computer generates the chromatogram, just like in GC. Okay. So how will you work? What is a typical experiment? So you take the mobile phase, you pump it at high pressure into the column, and through this injector, like in GC, you are injecting the sample, the mixture of components into this. The mixture gets absorbed here, and at different time intervals, each component will start coming out of this column. Okay, when it comes out, it is detected, and the result goes to the computer. Computer generates the chromatogram. This is a photograph of an HPLC, high pressure liquid chromatogram, and this is the syringe that you are using. Just like in GC, the only difference is this needle thickness is more compared to GC. GC has a thinner needle. Detectors. Detectors, there are two types of detectors here, bulk detector and solute detector. Bulk detector means it responds to the bulk properties of the mobile phase. For example, refractive index detector. Solute detector means it responds to the solute property. Solute means the component. Okay, properties of the component. Example, UV visible detector and fluorescence detector. So these are three important detectors: refractive index, UV visible, fluorescence. Discuss the various detectors used in GC and HPLC. That is a 6-mark question asked for a university exam. How does an experiment work? Stationary phase is packed into short stainless steel columns. A sample is injected into the column. The liquid mobile phase is passed through the column at very high pressure. The components come out at different time intervals and passes through the detector. Detector measures the amount of component as electrical signals, a plot of signal intensity against retention time, that is the chromatogram. So this is a sample chromatogram, just like in case of GC, same thing. You get different peaks. Okay, so each peak represents one component in the mixture, and the relative peak area is proportional to the composition. Relative peak area is proportional to the composition. So we can get how many components are present in a mixture, plus we can find out what is their amount, what is their composition. What are the applications of HPLC? Separate and identify non-volatile compounds as a quantitative analytical tool, separation of polypeptides, determination of cholesterol in food. These are some of the applications of HPLC. Advantage. What is advantage? Can be used for physical separation of non-volatile organic compounds. And this technique is, when we are using it for physical separation, it is called preparative HPLC. One disadvantage is it is not as versatile as GC. The range of compounds that can be separated is less compared to GC. So that is the disadvantage. So one question, detail the chromatographic technique used for separation of components in a non-volatile organic mixture. Or explain the principle, instrumentation, working and applications of HPLC. So these are two important university questions.